Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9s. Welcome to today's lesson for natural sciences. We are still looking at term 3, and the knowledge area is still energy and change. And please take note that this section contributes 80 marks towards your final examination, so please pay attention and take advantage of these marks because they are very easy to get. The topic for today's lesson, for a change, we are doing a new topic, that is resistance. And the subtopic for today's lesson is uses of resistors. I'm sure by now you know my name. I am Gwanele Dlamini, and this lesson is proudly brought to you by the Gauteng Department of Education. So let's begin. So what's the point of this lesson? What are we trying to achieve? What's the goal for this lesson? We are trying to ensure that by the end of this lesson, you should be able to explain that conductors heat up when current passes through them. You should be able to explain that conductors heat up when current passes through them. You should also be able to explain that some energy is lost or wasted from conductors as heat. You should be able to explain that some energy is lost from conductors or wasted from conductors as heat. You should also be able to describe what a resistor is. And you should be able to describe how a resistor works. And lastly, you should be able to list uses of resistors. Now, for more information on this, you know already, you can refer to the grade 9 CAPS document on page 73. So let's continue. So let's take a step back and look at concepts that we've learned in previous grades, because they lay a foundation for today's lesson. We're going to pick and choose the concepts that we've learned which are relevant for today's lesson. So starting from grade 5 and 6, we learned about electric cells. Now, an electric cell can be defined as the energy source in a circuit, or a broader meaning which is that an electric cell is a system in which certain chemical reactions can cause the flow of electricity through an external circuit. I'm going to repeat that. It's a system in which certain chemical reactions can cause the flow of electricity through an external circuit. That is an electric cell. So we know that when you have one of these, you call it a cell. But when you have two or more that are connected, then it becomes a battery. In most applications for our study of electrical circuits, we normally use the AA 1.5 volts cells, okay? So that's the common one that we use. Let's continue. In grade 7, we learned about national electricity. But what is the national electricity? Well, this is the electricity distribution from the power stations and all the systems involved until it reaches our households. For you to be able to plug your TV or your cell phone charger, there must be electricity generated someplace. Okay. Then in grade 8, we looked at the supply systems. But let's just do a quick revision of how this system works. You have coal coming from a mine delivered into a power station, and then we combust or burn that coal so that we can generate heat to heat up water to generate superheated steam. Then once we have that superheated steam, we use the energy from the superheated steam, the thermal energy, to drive turbines, right? And then the turbine converts the thermal energy into mechanical work to drive a generator. Then the generator will generate electricity. Then from there, we step it up through a step-up transformer so that we can compensate for the losses that are going to occur when the electricity is being transported through the power lines, okay? There are energy losses that occur during that because the power lines are running through long distances, right? And then after that, we put it in a substation, and from a substation, we put it in a step-down transformer. Then from there, we distribute it to our townships or suburbs, and then you are able to draw current from your socket plugs. Okay. And then We also learned about energy transfer in electrical systems. So let's just quickly go through this. So in an electrical system, from the power station all the way to your household, these are the energy changes that occur. First, we take thermal energy. We combust fossil fuel in the which is coal. We combust it, and when we extract thermal energy from it. Then that thermal energy is converted into, we use it to heat steam, right? That's still the thermal energy. Then that thermal energy is converted into mechanical energy in a turbine. The turbine uses mechanical energy and transfers it to the generator. The generator transfers that mechanical energy into electrical energy. Then once we have that electrical energy, once it reaches our homes, if we are going to use maybe a radio or speakers connected to a power source, then we are going to convert the electrical energy to a sound energy. If we are going to be watching TV, we are going to convert that energy from electrical into sound and light. If you're connecting light bulbs, you're going to convert it to what? Light and heat, okay? And of course, if you're using a stove, electric stove, you are going to convert that electrical energy into thermal energy to provide heat for your food to cook. Okay, I hope you understand it. Now that we've brushed on certain concepts that we've learned in previous grades, I think it's the perfect time to continue. But before we continue, I would like to remind you, if you have a question for us, you can bring it through to our WhatsApp line, which is 064 748 8913. That's 064 748 8913. If you have a question, bring it through. So let's continue. Now, let's do a baseline assessment just to test on how much of the concepts that you either already know or you're about to learn do you understand, okay? The first question that I have is, what is a resistor? Question 2, what is the unit of measurement of resistance? Question 3, what is a rheostat? And lastly, why do conductors heat up in an electrical circuit? So you have 4 minutes to work on these questions, and you're more than welcome to discuss with your friend. So when you're done, we are going to do the questions together, and I will provide you with answers. Welcome back, learners. I hope you were able to work through these 4 easy questions. And if you struggled with any of the questions, don't you worry, I will discuss it with you. Right, so the first question says, what is a resistor? Anyone has an idea? Yes, that is correct. A resistor is a conductor that opposes the flow of current through it. It's a conductor that opposes the flow of current through it. Right. Remember, a cell or a battery provides energy. It does work to drive current through a particular point in the circuit, and then it reaches a what? A resistor. The resistor is pushing back. So imagine the voltage is pushing this way, and the resistor is like, no, you can't pass this point. So the voltage is pushing the current through this resistor, but the resistor has a confined space and current is not able to pass through easily. Okay, that's what resistors do. They try to block or stop the flow of current. Okay, number 2, what is the unit of measurement for resistance? I'm sure everyone got this one correct because it's very easy. Yes, that is correct. It is the ohm. Okay, we use the symbol, the Greek symbol omega, for the unit of measurement of resistance. This is the Greek symbol omega. It represents what? The ohm, which is the unit of measurement for resistance. Question 3, what is a rheostat? Yes, that is correct. A rheostat is, you can define it as a variable resistor or a resistor in which the resistance can be manually changed. We can manipulate the resistance into what we prefer it to be in a rheostat. Unlike other resistors, they have a fixed resistance which we cannot change, but a rheostat has a resistance that we can manipulate. Okay. And the last question is, why do conductors heat up in an electrical circuit? Anyone? Yes, that is correct. The reason why conductors heat up is because of the resistance of the wires. Okay? Remember we said a conductor is a, okay, we said a resistor is a substance that tries to prevent the flow of current through it. So conductors they also have their own resistance, right? So this is because of the resistance of the conducting wires, which opposes the flow of what? Of electrons. The electrons bump into atoms of the outside the conducting wire and losing some of their kinetic energy in the form of heat, right? So when current is moving in the circuit, right, it's getting energy from the battery or the cell. And as it moves, remember when something moves, it moves at a certain velocity and it must have a mass. So it does what? It has a kinetic energy. Why? Because there's a velocity and a mass. And we know that kinetic energy is half mv squared. So when the electrons are moving, they have a kinetic energy. But then when they bump into the opposition to their flow or the direction of their flow, they end up losing some of that kinetic energy in trying to overcome this resistance, right? When they bump into the atoms outside of this conducting wire, they lose some of their energy in the form of they lose some of their kinetic energy in the form of heat, and hence the wire ends up, or the conductor ends up feeling hot. It ends up heating up. Okay. Now let's define a couple of terms that we are going to encounter in the lesson so that by the time we reach a term we don't understand, we don't need to go to Google or consult a dictionary to get meaning. If we define it now, we will understand it when we see it. So let's do that. The first term that we are going to define is a conductor. What is a conductor? A conductor is defined as a substance that allows the flow of electric charge through it. It's a substance that allows the flow of electric charge through it. Let's define another term, that is resistance. What is resistance? Resistance is the opposition to the movement of charge through a substance. It's the opposition to the movement of electric charge through a substance. Okay. Now, a resistor. A resistor is a conductor that opposes the flow of electric charge. Now, it's very easy to get confused with the definition of resistance and resistor. So let's try and bring the distinction between the two. Resistance is the action of opposing the flow of charge. Okay? A resistor is the substance that does the opposition of the flow of charge. Yes. So a resistance is the action of opposing the flow of charge, and a resistor is a substance that opposes. It does the opposing of the flow of charge through it. All right. Potential energy. Potential energy is energy that is stored in a system. It is energy that is stored in a system. Let us continue. A rheostat, we've already defined this in our baseline assessment. If you still remember, thumbs up. If you don't, here's a reminder. A rheostat is a resistor in which the resistance can be manually changed or manually manipulated. It's also called a variable resistor. It's a resistor in which the resistance can be manually changed. And it's also called what? A variable resistor. The next term is an ohm. We've also done this in our baseline. An ohm is the unit of measurement for resistance. We use the symbol omega. It's a Greek symbol called omega, right? It's a symbol for resistance. Okay, an ammeter. An ammeter is an instrument that we use to measure current in amperes. It's an instrument for measuring electric current in amperes. Now we have two types of ammeters. One is called the analog ammeter, and then the other one is called the digital ammeter. So let's talk about the analog ammeter first. The analog ammeter uses a needle, right? It has numbers. So when you connect it in a circuit, and it's connected in series, right? When you connect it in a circuit, the needle will move from 0 to whatever the current is. But the problem with the analog ammeter is that we have to read what the value is by checking the position of the needle. Now, if you do that, there is a chance of making mistakes because, you know, we are humans, we make human errors. So we prefer to use the digital ammeter. Why? Because this one gives you a value. You don't have to try and read between the lines where the value is. You just see a number and then you take that number as is. That is your current rating for that particular section of your circuit. So in most cases, we prefer using the digital ammeter because its accuracy is very good compared to the analog ammeter. But it does do the work. You just need to be careful not to make mistakes when you're reading the current. Now let's talk about resistors. What are resistors? Who can tell me what a resistor is? And where do we find resistors? Nice. Well, from your computer boards, can you believe that? There are resistors. Interesting. To your cell phone systems, they use resistors. And of course, your television sets, they also have resistors. So we have resistors in almost every electrical appliance. We use resistors in all of electronics. There is a resistor in one shape or form in all of electrical appliances. So in this lesson, we are going to look at how these resistors work, and hopefully by the end, we are going to understand exactly what they do and how they do what they do. So without any waste of time, let's talk about resistors. Right. So we're going to start by defining a conductor, because a resistor is a form of a conductor. A conductor is a substance that allows the flow of electric charge through it. A conductor is a substance that allows the flow of electric charge through it. Resistance is the opposition to this flow of charge. So resistance tries to oppose the flow of this charge that is flowing through the conductor. And a resistor is that conductor that opposes this flow of charge. So it opposes the flow of current or charge through itself. Right, so this is basically how this works. This illustration shows the relationship of current, resistance, and voltage. You have this guy over here is your voltage. It's doing work, applying a force to drive current, right? To drive current through this resistor. This resistor has a confined passage where current can pass, but only a limited amount of current is allowed to pass through at that point. So this is your resistor. It's like, no. You are not allowed to pass this point. But because the voltage is doing what? Work. It's applying a force to try and push this current through. The current is able to end up going in that direction. So in a nutshell, what you see here is voltage doing some work, applying a force. Then you have your resistor there trying to oppose. It's trying to oppose the flow of what? Of this current, which is I. The symbol for current is I, the symbol for resistance is R, and the symbol for voltage is V. Okay, let us continue. So we said that a resistor tries to prevent the flow of what? Of electric charge through itself. A resistor is placed in a circuit to control current or to provide useful energy transfer. Now, what do we mean by useful energy transfer? We know that in electrical systems, there are energy transfers. But what is a useful energy transfer? A useful energy transfer is when we convert electrical energy or any form of energy into an energy that we can use to accomplish a particular purpose. Like in the case of a light bulb. We use electrical energy to light up the bulb, right? To provide light, okay? But there's also another form of energy that is involved there. So the lighting up of the room, which is dark, where we convert electrical energy into light energy, that is the useful energy transfer, because we can use it to light up the room. But there is another energy that is lost or wasted, right, in the process. The wasted energy is the energy that we don't get to utilize in converting the electrical energy. So when you convert the electrical energy into light energy, there is energy that is wasted in the form of heat for a light bulb. The heat of a light bulb is so insignificant that it cannot provide warmth in a room, okay? So that's the energy that we lose. It's wasted energy. But the light energy is the useful energy transfer, okay? So now let's look at another example, which is basically the same as the one we did before. This is your voltage. It's propagating electrons. It's pushing electrons to move through the resistor. But the resistor is like, no, you can't pass this point. So it's providing resistance. But the end goal is for your current to pass through to the other side, okay? This is your voltage V, this is your resistance R, and this is your current I. Now, let's look at an example that we can all relate to. At school, imagine the siren just rang for you to go back to class after break, right? And your school principal sees that you guys are not running into your classrooms. So he takes his shambok just to scare you, and he's like, hey, go to your classrooms. And then all of you start running. Imagine there's only one classroom, right? Everyone has to run, and there's one door, and there's like maybe 50 of you. are all trying to pass through that door at the same time. That is an example of the relationship of voltage, current, and resistance. The door represents resistance because it only has a confined space where only a limited number of you can pass through at a certain point, at a given time. The school principal represents voltage because he's doing work to push you to pass through that door and get to your classroom. And you represent current because you are trying to pass through this small door, but only a limited number of you can pass at a given time. So that's the relationship of voltage, resistance, and current in a real life situation. Another example would be when you connect a hose pipe into a tap, right? And you open the tap. When you open the tap, there's going to be pressure that is applied to the water to drive it through the hose pipe. But if you bend one area of the hose pipe, maybe like midway, you bend it, right? We are creating what? Resistance. Why? Because you are confining the space where the water can flow. The water represents current, the tap represents what? Voltage, and the bend that you created represents what? Resistance. So you are creating resistance which slows down or limits the amount of water that can pass through, which represents current. I hope that brings clarity to the relationship of current, resistance, and voltage. Let us continue. So let's look at examples of resistors. We have a wide variety of resistors, but for the purposes of this lesson, we are going to look at 3. So resistors can come in all shapes and forms, and typical examples that we use or see every day would be light bulbs, right? We have different kinds and shapes of light bulbs, but they are all examples of what? Resistors. We have a not so common example, which is called what? A rheostat. We've already defined it. We can manipulate the resistance of the rheostat by moving this knob over here. We can move it to the left or to the right. When we move it this way, the resistance will decrease, and then when we move it that way, the resistance will increase. Okay. And then another example, which you're probably not very familiar with, is an electric motor. So an electric motor is a device that converts electrical energy into mechanical energy. Right. We use it. A particular application would be when you want to pump up water from a region of lower elevation to a region of a higher elevation. Imagine you have a tank on the ground and then another tank which is 5 meters above the ground. So in order for you to pump up a fluid or water through that height, you will need to pump it up to overcome the gravitational force that's trying to pull it down. Right. We use an electric motor to convert electrical energy into mechanical energy to overcome that height. Okay. So that the pump is able to drive the water from the ground to 5 meters above the ground. Okay. But there are also other applications of electric motors which you don't really need to know at the moment. Let us continue. Now, when electrons flow through a conductor, they encounter resistance. We've already explained this. When electrons are flowing through a conductor, they encounter resistance. The electrons bump into atoms outside of the conducting wires, and they lose some of their kinetic energy in the form of what? Of heat. So these are the electrons flowing through the conductor. But as they're flowing through the conductor, they encounter resistance of the conductor, and they bump into atoms outside of this wire, and they lose some of their kinetic energy, because we said kinetic energy is energy of moving. Yes, energy of motion. Okay, so whenever something is moving, it must have a certain velocity and it must have a mass, and the mass and the velocity can give us what? The kinetic energy. So they have a kinetic energy as they are moving, but they encounter resistance. When they encounter the resistance, which is trying to reverse their direction of flow or maybe limit the number of these electrons that can pass at a given point, while they bump through the atoms of the wire, they lose some of their energy in the form of heat. And that's why you find that a conductor is now feeling hot, or a resistor feels hot. That is because of the kinetic energy that is lost to generate heat. And you must remember that the law of conservation of energy says that energy cannot be created nor destroyed. It can only be transferred from one form to another. This is a typical example when you have your kinetic energy being transferred to heat energy. Let's continue. Resistance in an electrical circuit opposes the passage of electrons and is measured in ohms. Resistors can be used to provide useful energy transfer. Now, we've already defined what a rheostat is. It's a resistor in which the resistance can be manually changed. So this is an example of a rheostat, okay? We have this knob over here. We can move it to the left or to the right to change the resistance. And this is a what? This is a circuit symbol of a rheostat. Whenever you have a circuit diagram and you see this symbol, you must know that that's a rheostat. This is a circuit symbol for a rheostat. Okay. Now let's look at the resistance inside an electric kettle. I'm sure every one of you is familiar with an electric kettle because we all have them at home. We use it to boil water. Now, the electric kettle has a metal coil at the bottom inside the kettle. This is an example of a what? Of a resistor. When the electrons move through the resistor, they release a lot of their energy in overcoming the resistance. This energy is transferred into the water and it makes the water to heat up. It's transferred to the water in the form of heat and it causes it to heat up. That's why when you you put water in an electric kettle and you plug it in, you're going to see the water changing temperature over time, and then it gets to a point where it boils, where there's like a vapor liquid equilibrium and you see steam coming off the top. And this is basically what I'm talking about. You see the steam there, there's liquid there which is boiling. This is what is known as vapor liquid equilibrium at the boiling point of water. You don't need to know that. I'm just using it to illustrate. Okay. So some electric kettles may not have this thing at the bottom. This is the element, the metal coil, which is a resistor that causes the formation of heat inside the kettle. Some electric kettle have a plate at the bottom where you don't see this thing. But guess what's underneath that plate? It's this very thing, which is the metal coil that causes it to heat up. So in an electric kettle that doesn't have, that looks like it only has the plate. This thing is underneath the plate. It heats up and transfers heat into the plate, and the plate heats the water. It's the same thing, just that there's another layer added on top. Right, so let's look at resistance inside an incandescent light bulb. There's a thin coiled wire in the glass bulb called the filament. But before we move forward, I think we just need to clarify what do we mean by incandescent. Incandescent means lighting up, okay? It releases light and heat, okay? So there's a thin coiled wire in the glass bulb called the filament, right? There's these wires inside a light bulb. We call them the filament. And the filament is made from the tungsten wire. So tungsten is an element from the periodic table. Now, why do we use tungsten of all other metals that we could use? Well, tungsten has very good resisting properties which are suitable for light bulbs. So it has a very high resistance and it's a suitable resistor for a light bulb. Okay, so this is so when the electrons move through the filament, they experience high resistance, and of course once they experience high resistance, they will lose some of their energy in the form of what? Heat and light. Okay, this means that they transfer a lot of their energy to the filament when they pass through it. This causes the filament to give off light and heat. And this is what we are talking about. There's electric current coming from this direction, and it passes through this wire with a very high resistance. So when the resistance is high, we are going to lose a lot of our kinetic energy, right? So it loses a lot of its kinetic energy in the form of heat and light, and that's why you see the light bulb ending up glowing. It is because of the heat energy that is lost, and it causes the formation of light. And when you touch the light bulb, you're going to feel it. You're going to feel that it's actually hot. And this is what meets the eye. This is all we see, the light bulb glowing, but we don't understand the mechanism behind all of that. Okay, so now let's do some questions to test whether we understand what we have learned so far. Is it true or false? The element in an electric kettle is a resistor. Number 2, what is the wasted energy output in a light bulb? Okay, you have 2 minutes to work through these questions, and your time begins now. All right, learners, I hope you were able to work through those 2 easy questions. Now, without any waste of time, let's discuss the answers to these questions together. Right, first question, true or false? The element in an electric kettle is a resistor. What do you think? I'm very interested in your answers. Yes, that is correct. It is indeed true. The element in an electric kettle is a resistor. B, what is the wasted energy output in a light bulb? Anyone? Yes, that's correct. It is what? Heat. The useful energy output in a light bulb is light. Remember, useful energy is the energy that we can use, and wasted energy is the energy that we lose, which we cannot really use. Okay? So in a light bulb, we can use the light energy to light up a dark room, and the wasted energy is heat, which is insufficient to provide any warmth into the room. So we lose that energy in the process. It's a trade-off. We use electrical energy and we convert it to what? Light and heat. But we can only use the heat, not the light energy, and we lose the heat energy. Okay, now let's do our activity. First question, what is the resistor in the toaster? The toaster at home, what is the resistor inside it? Question 2, why does the element in the toaster glow? Question 3, what is the useful output energy in the toaster? And lastly, what is the wasted energy output in the toaster system? So you have 4 minutes to work through these questions, and you are more than welcome to discuss with your friend. And when you're done, we are going to revise the questions together. All right, learners, I hope you were able to work through these 4 simple questions. Now, let's take some time to go through these questions together. The first question was, what is the resistor in the toaster? Anyone? Yes, that's very correct. The resistor inside the toaster is the element. It's responsible for heating up the toaster, okay? So that you are able to toast your bread and get toasted bread from it. Question 2, what does the element in the toaster, why does the element in the toaster glow? Why does it glow? Yes, that is correct. When the current flows through the resistor, which is the element, some of its energy is lost in the form of light and heat, okay? When it heats up, some of its energy is lost in the form of light. So in the example of it, okay, I almost gave you answers to the other questions. No. Question 3, what is the useful output energy in the toaster system? Yes, that is heat. And lastly, what is the wasted output energy in the toaster system? Correct, that is light. So, can you see the difference here with the toaster and the light bulb? In the case of the light bulb, light energy was our useful energy transfer. And useful energy output, sorry, was light. Heat was what? The wasted energy output. But in the case of a toaster, we don't really need light energy. So it's our what? Our wasted energy output. And heat in this instance is our useful energy output because we transfer that heat to the bread and then it gets toasted nicely. Okay? Let us continue. Let's do 2 more questions and then we can wrap up our lesson. What is the scientific term for the electric component that is used to provide useful energy transfer? What is the scientific term for the electric component that is used to provide useful energy transfer? B, what is the scientific term for a resistor in which the resistance can be manually changed? Okay, so you have 2 minutes to work through these questions and your time begins now. All right, learners, I hope you were able to work on these 2 questions. Now, these questions look similar, but they are actually different. Okay, so first question was, what is the scientific term for the electric component that is used to provide useful energy transfer? Anyone? Yes, that is correct. It's called a resistor. Well done. Question B. What is the scientific term for a resistor in which the resistance can be manually changed? Can you see that question B gives you an answer to question A, but they are not the same question, okay? Just don't make that mistake. So what is the scientific term for a resistor in which the resistance can be manually changed? Yes, that is correct. It is called a rheostat or a variable resistor. It's a rheostat or a variable resistor. Okay, let's summarize our lesson so that we can have time to go through your WhatsApp questions. But before we do the summary, I would like to remind you of the WhatsApp line that is 064 748 8913. 064 748 8913. You can send your questions through and I will kindly assist you if you have any confusion or if you want to ask a question. Okay, let's summarize our lesson. We said that a conductor is a substance that allows the flow of electric charge through it. It's a substance that allows the flow of electric charge through it. We call it a what? A conductor. And we also said that resistance is the way in which a material opposes or attempts to prevent the flow of charge through it. Resistance is the opposition to the movement or the flow of electric charge through the resistor. Okay. A resistor is a conductor that opposes the flow of electric charge or current through it. A resistor tries to prevent the flow of electric charge. A resistor is placed in a circuit to control current or to provide useful energy transfer. So resistors do two useful jobs in a circuit. One, they control the flow of current, and the other, they provide useful energy transfer. Examples of resistors are bulbs, rheostats, electric motors, and etc. and etc. There are many kinds of resistors. Okay. We are going to talk about them in the next lesson, so you will see. Now we're going to take some time to go through your WhatsApp questions. Remember, the line is 064 748 8913. That's 064 748 8913. So you can bring your questions through and I will kindly address them. Let's go to the WhatsApp to see the questions. Okay, it's initializing. I don't know what's going on. Okay, we seem to be having problems with the WhatsApp line at the moment. Let's try again. Okay, WhatsApp is acting up today, so let's continue. Right. That brings us to the end of our lesson. Thank you so much for joining me for this lesson. I hope you learned something about resistors and how they work and how they are useful in controlling the current that flows through a circuit and the transfer of energy, the useful energy transfers. Now, before we close the lesson, I would like to give you a brief preview on our next lesson. In our next lesson, we are going to be looking at, series circuits. Yes, series circuits. So we are going to be looking at series circuits and we are going to learn about how to connect a series circuit and the effect and relationships of resistors and current. What happens when we add more resistors? What happens to the voltage, the current, and the relationships between the two? But what I can give you from that is that we know resistors in series as, yes, they are potential dividers. They divide the voltage coming from the cell or the battery. But what happens with the current? The current is constant throughout the circuit. But when we add more resistors, what happens to the current? The current drops. Yes, that is correct. So please stay tuned. In our next lesson, we are going to be looking at that, and I think it's going to be very interesting. We will be using a circuit board to demonstrate and take measurements, looking at how to use a voltmeter, looking at how to use an ammeter, and how to connect the ammeter and the voltmeter. The voltmeter is usually connected in parallel, whereas the ammeter is connected in series. Now, the reason for that is very simple. It is because the voltmeter has a very high resistance. If we were to connect it in series, there would be no current flowing. But in the case of an ammeter has a negligible resistance. So it works to connect it in series because its resistance will be negligible. Okay, now when you finish the lesson that you are watching right now, I would like you to go to the bottom of your page, your screen. You are going to see something that says, a button that says complete and continue. When you get to that, you can click and you are going to get a message that says, congratulations, you have completed your lesson, and you will get bonus points, right, for your participation. So I would like to thank you for joining me in this lesson. It's been a pleasure delivering you a lesson on resistance and their uses. So what I need you to take from this is, let's just do a little quick reinforcement of what we've learned. We said that a conductor is a substance that allows current or electric charge to flow through it. And we said that a resistor is a conductor or a substance that opposes the flow of electric charge through it. And we said that resistors are useful because they help us control the current flowing through the circuit. And they are also useful because they help us do useful energy transfers. Yes, that is correct. So that brings us to the end. I know I've been talking for a long time. Thank you so much for joining me. It's been a pleasure for hosting you for this lesson. What I need you to do from now is take care of yourself, wear your mask, keep your distance, and keep safe until we meet again for our next lesson, where we are going to be looking at what? Yes, series circuits. Take care.